Hi there and welcome to another video for the AQA Linear GCSE Higher paper. This is the last video. It's practice paper for the calculator paper. Let's work our way through it. To make 30 biscuits you need the following. What do you need to make 45? Well, the first thing I do is talk about 15 biscuits because it's half of this. Okay, so 15 biscuits easily would be half of this, so it would be 150 grams, it would be 125 and it would be 70. So therefore, 45 biscuits would be 3 times this, so it would be 450 grams. It would be 3 times that, which would be 375 grams, and it would be 3 times that, which would be 210 grams. So 450, 375, and 210. Okay, so clearly show that you've done 15 and 45 biscuits. So 15 would be halve it, and then 45 would be times by 3. Show that above. Perhaps I didn't show that clearly. I should have shown that above as follows. Okay, the perimeter of this rectangle is 43. Set up and solve an equation for x. It's a rectangle. This side must be x subtract 2. This side must be 2x plus 1. If you add all these distances, it must be 43. So x subtract 2, we've got 2 of them, and we've got 2 of 2x plus 1s, and they must add up to 43. Expand the brackets. 2x subtract 4 plus 4x plus 2 must equal 43. Collect like terms. 2x add 4x is 6x, and negative 4 add 2 is negative 2, would be 43. And then add 2 to both sides. 6x must be 45. Divide both sides by 6. 45 divided by 6. Tap that into your calculator and you get 7.5. Okay, double check it works. If that's 7.5, this here would be 5.5, this would be 5.5, this here would be 2 times 7.5 is 15 plus 1, so it would be 16, 16. 5.5 and 5.5 is 11, 16 and 16 is 32, 11 and 32 is 43. I got it right for 5 marks. Question 3. Sally wants to know whether students in her school can swim or not. She also wants to know whether they're boy or girls. Design a two-way table. Simple as this. Along the top would be gender, and you would put boy, girl. And down the side you would swimming, and say swim, not swim. Simple as this, and then it's two-way table, so just make sure you've labelled it out as follows, and there you go. It's as simple as that there. 2 columns, 2 rows. Okay? Next. This is a regular pentagon divided into 5 congruent triangles. That congruent means they're all the same. So this triangle is the same as this, is the same as this, etc. Work out the size of angle x. We want to know what, how big that angle is there. Well, if they are congruent triangles, that angle and that angle must be the same. Okay? Because the triangles are equal to each other. Now you also know, if this is the exterior angle, you know the exterior angles of any polygon add to 360. So therefore this exterior must be 360 divided by 5. Okay, and 360 divided by 5 is equal to 72. So this is equal to 72 degrees. Therefore the interior one, so the interior must be 180, subtract 72, which is equal to 108. So 2 lots of x are 108, 2 of these interiors are 108, so 1x must be half that, which is 54 degrees. Question 5. Here's a linear sequence. Work out the rule from getting between one to the other. A third, a half, 2/3, etc. How do you get from one to the other? As it's linear, you know it must go up in a constant amount. Let's work that amount out. A half, subtract a third, make them both over 6, so that'd be 3/6, subtract 2/6, which is 1/6. So they must be going up in 1/6. Just to double check that, let's do 2/3, subtract the half, check they are going up the same. Make them both over 6, so that'd be 4/6, subtract 3/6, which again is 1/6. So the rule is add 1/6. Work out the next number in the sequence. Well, it must be 2/3 plus a sixth. Make them both over 6, so that would be 4/6 plus 1/6, which of course is 5/6. Next question, ABCD is a parallelogram. A and B are shown. So A and B are as follows. The area of the parallelogram is 15 centimeters squared. Write down the coordinates of C and D. Okay, if it's a parallelogram and it's 15 centimeters squared, let's work out the height of this parallelogram. The right angle height there is 5, so it must be 3 across. So it must be, let's say, 3 across here and 3 across here. That could be C, that could be D. And then you could draw it in as follows. Then you would know the base is 3, the height is 5, hence you would get 15. So the coordinates therefore are 6, 1 and 4, 6. So 4, 6 and let's say 6, 1. It doesn't matter what you call these. A, B, C, D, you should probably go A, B, C, and D. It should be probably that way around, but it doesn't really matter. As follows. Electric cable is sold in a cylindrical drum. The diameter of the drum is 30. So the diameter, the distance from there to there, is 30 centimeters. Therefore, we should know that the radius is 15 centimeters. Cable is wrapped around the drum 20 times without overlaps. An electrician needs 75 meters of cable for the job. How many drums does he need to buy? So, let's work out how much cable in a drum. Okay, the cable in the drum is 20 lots of the circumference. 20 multiplied by the circumference, because it goes around 20 times. So 20 multiplied by 2 pi r, which is actually 40 pi r, which is 40 multiplied by pi multiplied by 15 in this case. And it would be 40 times 15 times pi, which is actually 600 pi, or 1885 centimeters. So therefore, and that in meters must be 18.85 meters. So therefore, if you need 75 meters of cable, 75 divided by 18.85, you get yourself 3.97, which actually rounds to 4 drums needed. Next, question 8. A factory makes 2,000 CDs. The probability that a CD is chosen at random is not faulty is 0.992. How many CDs are likely to be faulty? So this is not faulty. The probability that it's faulty would be 1 subtract 0.992, which of course is equal to 0.008. Therefore, out of 2,000 CDs, 2,000 multiplied by 0.008 would give you how many CDs you would expect to be faulty. And the answer is about 16. So 16 is your answer. Question 9. The table shows heights of 250 trees in a wood. Which group contains the median? So in total, how many trees are there? We know there are 250. The median therefore happens at about 125th position. 125th. So this is 31. This here would be 65 plus 54. The total up to here would be 119 plus 63 would be 182 plus 68 would be the 250. Therefore, the median must occur in this group here. The 125th person must occur here, or tree even. So it would be 15 less than h less than or equal to 20. State your group as it's shown there. Calculate an estimate for the mean number of trees. If you want to work out an estimate for the mean number of trees, go back to this diagram here. For an estimate of a group table, take the median, the middle value of the group, and then multiply the frequency by the median. So 34 then times 7.5, 255, 54 times 12.5, 675, 63 times 17.5, 1102.5, 68 plus 22.5, 68 times 22.5 is 1530. If you add these up, get yourself a total of 3640. So an estimate of the mean, therefore, is 3640 divided by 250. And you get yourself 14.6 meters. Do show all your working all right here, see table. Explain why the range must be between 15 meters and 25 meters. Looking back here, why is the range between 15 meters and 25 meters? Well, the range is the biggest, subtract the smallest. Now it could be, looking back at our table, this here, it could be 25 at most and 0 at the least, effectively. So it could be 25 take away 0 is 25, or it could actually just be 20, it could be the lowest number here, take away the biggest number here, so it could be also 20 take away 5 is equal to 15, and then write due to grouping. Because we don't actually know what values are in here, it could be 5, it could be 20 roughly, or 20.0001 or something. Okay, tins of soup are packed in a box as shown. The cost of each tin is 46p. After a 15% discount is given when a box full of tins is bought. Work out the cost of the whole box. So, looking at the box here, we've got 1, 2, 3, 4, 5, 6 can fit across, 2 can fit up, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 can fit back. So therefore, number of tins must be 6 times 2 times 10, which is 120 tins. Okay, they're 46p each, so 120 multiplied by 0.46 will give you 55.20 pounds, and a 15% discount is given, so that's like multiplying by 0.85 or 55.20, so therefore it's £46.92. Okay, next one, complete the table for the following. Take the number x, square it, add 2 lots of x and take away 1. So let's do this with minus -1. -1 squared plus 2 multiplied by -1, subtract 1. -1 squared, -1 times -1 is 1. Positive 2 times -1 is -2, subtract 1. 1 take away 2 is -1, take away 1 is -2. Let's do the same with 2. 2 squared plus 2 times 2, subtract 1. 2 squared is 4, 2 times 2 is 4, take away 1, you get 8, take away 1, which is 7. Okay, and then we're asked to draw the graph here. So x is -3 goes with y is 2, -3 goes with y is 2, -2 goes with y is -1, so there. -1 goes with -2 there. 0 goes with -1, 0 goes with -1 there. 1 goes with 2, 1 goes with 2, 2 goes with 7 and 3 goes with 14. So 2 goes with 7 and 3 goes with 14. And then you draw yourself a parabola linking them like that. Just be careful to go through all the points. Use your graph to find the solutions to x squared plus 2x subtract 1 is 0. Where is this graph? Where is this equal to 0? Where is the y number equal to 0 is another way of saying that. Well, the y number is equal to 0 here and here. And what x values are they for? That's x is approximately 0.4 and x is approximately -2.4. Okay? So I would say 0.4 and -0.24. Sorry, -2.4. Work out the area of this trapezium. Well, this is given in your formula booklet. The area of a trapezium is equal to half a plus b multiplied by h. So the area here must be a half. 65 plus 38 multiplied by 80. So 65 plus 38 times a half times 80. That would be equal to 4120 centimetres squared. And then for part B, use your answer to part A to work out the volume of the prism. Volume of the prism is the area of the surface area times the depth. Well, it's the same prism it's the same trapezium as in the last question. So it's 4120, the front surface here, multiplied by 110. So 4120 multiplied by 110. And the answer is 453,200 centimetres cubed. And you're done. That's nice and easy. Next question, it asks us to work out the gradient of the line segment AB here. So we'll remember that the gradient is the difference in y's divided by the difference in x's. Okay, and the difference in y's between here and here, well, it goes up 6, so it's 8 subtract 2, which is 6, divided by 5 take away 0. So it's 6 over 5, and that's the gradient. I might call that m. And part B says, write down the equation of the line in the form y equals mx plus c. Y is equal to mx plus c. Remember what these mean. The m is the gradient, and the c, the plus c, is the y-intercept. Okay, what value y is when x is 0, where the graph crosses the y-axis. So looking back here, we know the gradient is 6 over 5 and it crosses at 2, so therefore the equation is y is equal to 6/5 x plus 2. Simple as that. Question 14. A car travels 30 miles for each gallon of petrol. The fuel tank has 36 litres of petrol. How many miles can the car travel before it runs out? Now, there's one conversion you need to know here, and that conversion is as follows. You need to know that 1 gallon is about 4.5 litres. Okay, or sometimes I remember it as 2 gallons is about 9 litres. Okay, so a car travels 30 miles for each gallon of petrol. The fuel tank has 36 litres of petrol. So 36 litres, how much is that in terms of gallons? Well, you know, from here, you know that 9 litres is 2 gallons. Therefore, 36 litres must be 4 times that. 36 litres must be equal to 8 gallons. So that's approximately 8 gallons. And it travels 30 miles for each gallon. So therefore 30 multiplied by 8 is equal to 240 miles. Okay, so one to remember for you there, a conversion to remember. Just do remember this, 1 gallon is approximately 4.5 litres. You're expected to know that. Even if you forgot that, approximate. You know a gallon is more than there's more volume in 1 gallon than there is in 1 litre. So you know 1 gallon is some lots of litres over 1. Just remember it being 4.5 from now on. A light is fixed in the middle of a rectangular ceiling. Work out the distance between the light and the corner of the ceiling. So the light and the corner. So you want this distance from here to here. Okay, so we're going to call that D. Well, we know this distance here, and it's exactly in the middle, so it's half of 5.5, and half of 5.5 is 2.75. So this distance here is 2.75, and we also know this distance here, which is half of 3.5, and half of 3.5 is 1.75, so this is 1.75. By doing this, we've formed a right angle triangle, and we can use Pythagoras. We know that d squared must be equal to 2.75 squared plus 1.75 squared. So 2.75 squared plus 1.75 squared, that's equal to 10.625. That's d squared. So d must be the square root of 10.625, which is equal to D is equal to 3.2596, and the suitable degree of accuracy, well, everything was given to 1 decimal place, so we should give to 1 decimal place. The answer would therefore be 3.3 meters. Okay, to 1 dp, and we'll be done for 5 marks there. Okay, next, ABC is a right angle triangle. Work out the value of x. So we want to work out this angle here. Okay, we know that is equal to 2x, and we are told this is y here and this is y here. So how could we work out the value of x? Well, it's quite easy. You know that's 90 degrees, and inside this triangle ADB or ABD, we know it must add up to 180. So 2x plus 90 must add to 180. So combining x is 3x plus 90 must be 180. Subtracting 90 off both sides, 3x must be 90, and then dividing by 3, x must be 30 degrees. So work out the value of x is 30. From that, put in your diagram, this here must be 30 degrees. This here is 2 lots of x, which is 60 degrees, right? Okay, then it says work out the value of y. Well, looking back at your picture, this angle here must be 150 degrees. Okay, so because it's on a straight line with x. So call the angle DCB. So state that DCB, the angle that's there, must be 150 degrees on straight line with x. But also, you know, these two are both y. So this must be an isosceles triangle. So to the left over, these two therefore must add up to 30, considering this triangle here. 2y must add up to 30, so 2y must be 30, so 1y must be half that, which is 15 degrees. And right in here, 15 degrees. Done for another easy mark. Okay, we're asked to factorise the following here, and then we're asked to simplify some algebraic fractions. Now, factorise this. We want two numbers that multiply to positive 15 and that add up to negative 8. Can you think of two numbers that do that for us? Well, yes, the two numbers that do that for us are negative 5 and negative 3. They add up to negative 8 and they multiply to positive 15. So it'd be x subtract 5, x subtract 3 is our answer. Now, we have seen these in the last 3 videos. We are told to hence simplify this. Now, when you're simplifying algebraic fractions, step 1, you should remember this now. You factorise top and bottom. Okay, and then step 2, you cancel. So let's have a go at factorising top and bottom. We have done part A. We have factorised the top. We know it factorises to x subtract 5, x subtract 3. The question is, what does the bottom factorise to? Well, let's do some separate working. Let's try and factorise 2x squared subtract 5x subtract 3. If we're trying to factorise something like this, step 1, 2 multiplied by negative 3 is negative 6. Step 2, we're trying to find two numbers that multiply to negative 6 and add up to negative 5. Can we think of two numbers that multiply to negative 6 and add to negative 5? Well, negative 6 and positive 1 do that for us. So therefore, if we're trying to factorise this, we would write 2x subtract 6 and 2x plus 1. And we try and cancel where appropriate. This one can be cancelled to x subtract 3, 2x plus 1. So the bottom here factorises to x subtract 3, 2x plus 1. You could have also just done that by inspection. And oh look, x minus 3 cancels off top and bottom, and you're simply left with a simpler fraction, x subtract 5 on top and 2x subtract plus 1 on bottom, and you're done. Now, with something like this, I know we did some working over here. I'm just going to go over in a different pen here and try and factorise this. See if you can spot how I did this. 2x squared subtract 5x subtract 3 by inspection. Imagine you just looked at that. In order to get 2x squared, you know that you must have 2x in one bracket and x in another. Then, in order to get the negative 3, the only things that times negative 3 are negative 3 and 1 or positive 3 and negative 1. So it's got to be one of these in the brackets so that we get a negative 5x when we expand out. Well, if you put a negative 1 and a positive 3 there, you get your negative 3 times in. But here you would get negative 2x plus 3x, which is plus 1x. So it can't be that way around. Could it be plus 3 and negative 1? Well, then we would get a plus 5x in the bracket. So it can't be that. So could it be plus 1x? Could it be plus 1 here and subtract 3 here? Well, yes, it turns out to be that way around. So you can get this by trial and error as well, or you can use the long method here. Okay, write these numbers in order of size, starting with the smallest. You must show your working. Okay, we've done this question quite a few times now. Okay, so 15 to the 2/3. We would write that as 15 to the 1/3 squared. Oh, sorry. We wouldn't even need to do this. Apologies. This is a calculator paper. We just type in our calculator 15 to the power of 2/3 on our calculator, and we get ourselves 6.08. So 15 to the 2/3 is equal to 6.08. 215 to the 1/3 is equal to 5.99, and 20 to the 3/5 is equal to 6.03. And then you have to put them from starting with the smallest. So the smallest one is clearly this one, 215 to the 3rd. The next smallest one is this one, 20 to the 3/5, and the next smallest one is 15 to the 2/3. Probably the easiest 2 marks on the paper, given you've got a calculator and all you've got to do is substitute in. Okay, question 19. A school has students in year 9, 10 and 11. A 10% sample stratified by gender and group is to be taken. Complete the table below. So we want 10% of the of each of these groups in our sample. Firstly, let's work out the total of our population, the total of our entire population. So that'd be 136 plus 130 plus 141 plus 142 plus 94 plus 105. We've got 748 in total. And in total in year 9, we've got 136 plus 130. We've got 266 in total here. We've got 141 plus 142, 283 here. And we've got 105 plus 94, which is 199 here. And total boys, 136 plus 141 plus 94, we've got 371. And 130 plus 142 plus 105 is 377. Okay, so it's just handy to have those totals there, handy for that. Okay, next we want 10% of each group. Now 10% of that is going to be 13.6. So I'm going to round that up to 14. 10% of that is going to be 14.1, so I'm going to round that down to 14. 10% of that is going to be 9.4, which I'm going to round down to 9. And what would 10% of the number of boys be? It would be 37. Does this add up to 37? 14 plus 14 plus 9. It does add up to 37. Okay, 10% of this is going to be 13. 10% of this would be 14.2, which I'm going to round down to 14. 10% of this is going to be 10.5. I'm probably going to try and round that up as long as this adds up to 10% of this would be 37.7, which I want to be 38. Double check that adds up to 38. 13 plus 14 plus 11, it does add up to 38. These two added together, 38 plus 37 is 75, which is 10% of that rounded as well. So this adds up to the 75 we were looking for. Okay, the diagram shows a sketch of a graph x squared plus some lots of x, b lots of x, plus c. It asks us to work out the values of b and c. Well, it tells us some key points. Here, we know that when x is 1, it crosses the x-axis, y is 0, and then here, when x is 7, y is also 0. So let's substitute x equals 1 in, and we know that y is 0 at that point. So let's do that. Sub in x is 1, y is 0. We would get the equation 0 is equal to 1 squared plus b lots of 1, which is b, plus c. And this simplifies to 0 is 1 plus b plus c. Okay, and there we have an equation. The next one, let's substitute in x is 7 and y is 0. So we sub that in here, we get 0 is equal to 7 squared, which is 49, plus 7b plus c. Okay, so we have ourselves two equations. Here's equation 1, here's equation 2. We want to find b and c. We've got simultaneous equations. If I did equation 2, subtract equation 1, 0 take away 0 is 0, 49 take away 1 is 48, 7b take away 1b is 6b, and c take away c is nothing. That helps us eliminate the c. Rearranging this, subtract 48 from both sides, and divide by 6, b must be equal to negative 8, so b is negative 8, and sub it back in one of these equations to get what c would be. Let's put it in there. 1 plus negative 8 is negative 7, so negative 7 plus c is 0. Add 7 to both sides, c must be equal to 7. Okay, and therefore we've got our b and our c. Okay, the price of a TV decreases 15% each year. The price of a 2-year-old TV is £433.50. Work out its price when it was new. You need to remember the following. The new price, okay, is the percentage multiplier multiplied by the old price. Okay, so we in this case want to work out, it's confusing how I've written new and old price there. I won't write that. I will write the current price. I'm going to write the current price is the percentage multiplied by the original price, okay? So the current price that the TV is worth, the current value of the TV is the percentage multiplied by the original price. Now we want to work out its original price when it was new. We want to work out this here. Now, we know what happened was its current price is 433.50. And what happened? Each year it reduced by 15%. So the first year it reduced by 15. We multiplied by 0.85. The second year it reduced by a further 15%. Okay, and we multiply that by the original price, and that would tell us the new price. So the original price therefore must be 433.50 divided by 0.85 squared. So 433.50 divided by 0.85 squared, and we get £600. So we get for this £600. Question 22. A bag contains 2 black, 5 green and 3 yellow counters. 2 counters are chosen at random. Work out the probability that they are the same colour. Okay, if 2 counters are chosen at random and are taken out of the bag, then we've got to assume that one's taken out and then the other's taken out next. Okay, so let's draw a tree diagram to represent this. Okay, we can either take out black, green or yellow. Okay, now the probability of black is 2 out of 10. Probability of green is 5 out of 10. And the probability of yellow is 3 out of 10. Having done that, then we can either get blue, green or yellow again. If you've taken a blue out, there's only black out, there's only 1 black out and 9 left. Green, there is still 5 out of 9, and yellow, there is still 5 out of 9. And it works the same for all the different branches, okay? So here it's going to be hard for me to draw these. So either we get blue, green or yellow. Blue would be 2 out of 9, green would be 4 out of 9, and yellow would be 3 out of 9. And the last one here, we either get blue, green or yellow. Well, blue is going to be 2 out of 9, green is going to be 5 out of 9, and yellow is going to be 2 out of 9. What's the probability that they are the same colour? Either that is the probability that you get blue, blue, plus the probability that you get green, green, plus the probability that you get yellow, yellow. By looking at the tree diagram, it's 2/10 times 1/9. This times this is 5/10 times 4/9 plus 5/10 multiplied by 4/9. Okay, plus yellow, yellow, 3/10 times 2/9. 3/10 multiplied by 2/9. So it's just a case of tapping this in your calculator. And you get yourself, when you do that, 28 over 90. 28 over 90, which simplifies to 14 over 45. Okay, so perhaps I showed it not so well there. Take space to draw out a proper neat tree diagram. Mine's a bit messy there. Take some space to do it and make it nice and neat. Okay, prove that the following is identical to this. So prove that this is identical to this. Start with the left-hand side and let's manipulate the left-hand side till we get the right-hand side. The left-hand side is 2n plus 1. Put brackets around everything when you copy out the question, but put brackets around everything. Subtract n over n plus 1. This will encourage you not to make mistakes when you're cancelling or multiplying. Now, we've got an algebraic fraction here. We cannot subtract an algebraic fraction until the bottom numbers are the same. Therefore, we need to multiply this one. The lowest common multiple of 2n and n plus 1 is 2n multiplied by 2n plus 1. So this one has to be multiplied by n plus 1. This one has to be multiplied on top and bottom by 2n. So I'm going to write that very clearly like this, keeping my brackets everywhere so I don't make a silly mistake. What did I say? This one needs multiplying on top and bottom by n plus 1. And this one needs multiplying on top and bottom by 2n. Now they have the same common denominators and you can combine the tops. So this would be equal to 2n plus 1, n plus 1, subtract everything you get when you do n multiplied by 2n, all over 2n, n plus 1. Okay, now it's just a case of expanding this out. 2n times n is 2n squared, 2n times 1 is 2n, 1 times n is 1n, 1 times 1 is 1. Subtract n times 2n is 2n squared, all divided by 2n, n plus 1. Look what happens here. The 2n squared, subtract 2n squared is nothing, and we've got 2n plus n is 3n plus 1. So we get equals 3n plus 1 over 2n, n plus 1. Okay, and we got ourselves the right hand side, and we're done for 4 marks. Next question. Work out the volume of the hemisphere of radius 15. Well, you were given in the formula book, there's no excuse for not getting this question. You were given that the formula of a whole sphere is 4/3 pi r cubed. So the volume of a hemisphere is half that, must be 2/3 pi r cubed, which you just substitute in 15 here. The easiest question on the paper, perhaps, 2/3 times 15 cubed. So just go away, type in your calculator 2/3 times pi times 15 cubed, and you get yourself 7068. So you get yourself 7068.58 centimeters cubed. This was given to 2SF. You should probably give your answer to 2SF back. So 2SF, it would be 7100 centimeters cubed to 2 significant figures. Okay, question 25. The diagram shows the triangle ABC. The lengths AB and BC are given to the nearest centimetre. This is a question about upper and lower bounds. Okay, work out the maximum possible length of AC for 4 marks. Okay, now the maximum possible length of AC must occur when this is maximum and this is maximum. So AB, the upper bound of that, well, if it's measured to the nearest centimetre, you halve that in 0.5 centimetres and you add it on. So AB max is 6.5 centimetres. BC max must be 8.5 centimetres. They're the upper bounds. And if they are slightly bigger, that will make AC the biggest possible. Now, how can you work out AC? Well, you don't have a right angled triangle, so it's either the sine rule or the cosine rule. Do you have a length and a side opposite and an angle opposite? No, so it must be the cosine rule you use. If you want to work out AC squared, you look in the front of your formula booklet and it tells you this is the side we're trying to work out. It tells you A squared is equal to B squared plus C squared minus 2BC cos A. Okay, this is the length you're trying to find out. Call that little a, call the angle big A, and call these B and C in any order. Okay, so AC squared must be equal to 6 squared plus, sorry, not 6 squared, 6.5 squared, because we're using the maximum here. We're trying to find the maximum. So it's 6.5 squared plus 8.5 squared minus 2 multiplied by 6.5 multiplied by 8.5 cosine of 110. Okay, so AC therefore is the square root of that when you get the answer to it. So you could type that in one move on your calculator. You could just type the square root of bracket 6.5 squared plus 8.5 squared minus 2 brackets 6.5 brackets 8.5 brackets cos 110 close brackets, and you get yourself 12.3. So that would give you 12.3 units centimeters as a maximum. Okay, next question. X is 8.3 times 10 to the 5, y is 2.4 times 10 to the 6. Work out the value of x plus y, give your answer in standard form. On your calculator, just type 8.3 times 10 to the 5 plus 2.4 times 10 to the 6, or using the x button, some calculators have that. So 8.3 times 10 to the 5 plus 2.4 times 10 to the 6. On my calculator, it gives you the answer 3.2. No, it gives you the answer 3230000, which you have to give your answer in standard form. So you write 3.23 times 10. So imagine the decimal point was there, times 1, 2, 3, 4, 5, 6, times 10 to the 6. Work out the value of x times y. Again, just in your calculator, do 8.3 times 10 to the 5 times 2.4 times 10 to the 6. See what your calculator says. put brackets around your standard form just to make sure you don't make a mistake. 2.4 times 10 to the 6. And my calculator gives me the answer straight away as 1.992 times 10 to the 12. Really no excuse for not getting these right, especially given it's a calculator paper. Okay, and question 27, the last question, which is unbelievably easy. It is solve the quadratic, give your answer to 2dp. When it says give your answer to 2dp, you are supposed to use the quadratic formula, which is given in your formula booklet as negative b plus or minus the square root of b squared subtract 4ac all divided by 2a. Okay, now the way I do this, I firstly work out b squared subtract 4ac. I think it's a lot easier. So state your a, b and c. A is 2, b is, be careful, negative 4, and c is, again be careful, negative 5. First things first, work out b squared minus 4ac. b squared subtract 4ac. That means negative 4 squared, substitute into brackets, subtract 4 brackets, a is 2 brackets, c is negative 5. Negative 4 squared, 16, and then if you do subtract, so if you do 4 times 2 times negative 5, you would get subtract negative 40, which turns out to be 16 plus 40, which is 56. Okay, so now we can just substitute in. X is therefore negative b on the one hand, so it would be negative 4, be plus 4, plus the square root of 56 all over 2a, which is 2 times 2 is 4. Or x on the other hand would be negative b again, be 4, subtract the square root of 56 all over 4. Now it's just a case of tapping those into your calculators and rounding to 2dp. So on top, 4 plus the square root of 56 all divided by 4, and I get myself 2.87 for that one, rounded, and then go back up and then do 4 subtract root 56, and you get negative 0.87, negative 0.87. So your answers are 2.87 and negative 0.87. Very, very easy to finish a paper off. Okay, and that's it for this particular paper, and they are all the papers that have come up for the linear. So if you've worked through all these, you have everything you need for the exam in January. Thank you for watching.